So we have a row at top left of a matrix, and we have to find the number of unique ways in which it can reach bottom right. Though there are some conditions like it cannot cross obstacles in between, also it cannot move left or upwards. It can only move towards right and downwards. If we see the example in the question, there are only two ways: right, right, down, down. So right, right, down, down. This is one way, and the second is down, down, right, right, down, down, right, right. So these two ways we can reach bottom right here. Let's take this example. In this, the robot can go 1, 2, and 3. There are three ways in which the robot can reach from top left to bottom right. Please note that it cannot cross the obstacle and add a fourth way to it. Let's think locally how many ways a cell can be reached. If we want to move to this cell, there is only one way. You cannot move till this cell and reverse because moving left is not allowed. Similarly, you cannot move this way either because moving upwards is not allowed. So there's only one way this cell can be reached. Similarly, this cell can be reached only one way. If we want to know how many ways this cell can be reached, it can be reached this plus this. So basically the sum of left cell plus the right cell. So the answer for this would be 2. Let's verify it again. The number of ways this cell can be reached will be 1. Why? Because it can move only from this cell to here, and this cell itself can be reached in one way only. So there's only one way, that is right, right, that this cell can be reached. Building on the same logic, and since we can reach this cell in only one way, we can also reach from cell above it to this cell in one way. And from the left cell, we can see we can reach to the left cell in two ways. 1, 2. So basically we can move from here like 1 and 2 ways. So the answer for this cell would be 3. In a very similar manner, this cell can also be reached in one way only. So if we want to calculate the number of ways in which the last cell can be reached, it's gonna be the number of ways in which the cell above it can be reached plus the number of ways in which the cell towards left of it can be reached. Since the left of it is obstacle, we won't consider it, we'll only consider the one above it. So the total number of ways in which the last cell can be reached is 3 in this case. Okay, let's discuss the base cases first. What if the position at which robot is supposed to be, the top left corner, that is already taken by an obstacle? In that case, our robot cannot move anywhere, and the number of ways would be 0. So our answer would be 0 in that case. So let's write that if our obstacle grid 0th row and 0th column equals 1 means there's an obstacle. Otherwise, let's initialize our DP array. And the length of it's gonna be same as the obstacle grid's length, and for the columns as well, we'll copy down the number of columns it had. If you remember, each cell, the value in each cell will depend on, if you remember, the answer for each cell depend on the previous cells. So if we keep moving in that logic, the very first cell has to contain some value. You see, for the second cell to contain for the second cell in the first row to contain one value, you have to have some value at the very starting cell, which would be 1. So we'll just say in 0 with 0 is 1, and now we can continue from here. So let's say for each row and for each column For okay, so let's say for each row and each column, what we will see is if the so for each row and each column, what we'll see is if the current cell is not a obstacle, so obstacle I is to j is not equal to 1. In that case, what we want to do is we want to add the left cell, and then we want to add the right cell, the above cell to it. So for each row and each column, what we're gonna do is if the current cell is not a obstacle, so if obstacle grid I as to j is not equals 1, only then we're gonna add cell above it and add cell to left of it. So we'll say dp of ij equals dp of ij plus the previous row and the same column. Similarly, we'll do for the left one as well. We'll say I with j minus 1. But remember, if at the top row, you cannot add the row above it because there's no such row. So we'll simply say if I is greater than 0, only then we want to add the cell above it, because otherwise there won't be any cell above it. And similarly, we want to do this if j is greater than 0, only then we want to add the cell to the left of it. And once we have built our array completely like this, what we want to do at the end is just return the cell at the very end. So we'll just say return dbase length minus 1, which is the last row with the last column of the last row. Let's run our test cases and see. We got expected I00 equals 1. Okay, it has to be dp. We just mentioned it. Yeah, mistakes like this keep happening, so it's fine. I'm not gonna remove it. And you see, both our test cases have passed. Let's submit it. We can see all our test cases passed, but I have a challenge for you at the end. You see, we used a two-dimensional matrix for the dp. Can you do it in one-dimensional array?